Okay, let's talk about 5.2, the multiplication principle for inequalities. And you can find this on starting from page 7. Okay. Very similar to the multiplication for inequality, but there are differences. Okay, in this case, I'll tell you what the difference. But for now, there are two cases here. Given A, B are real numbers, and C is any positive number, we have these two equivalent inequalities. If A less than B, then if you multiply C on both sides of this inequality, it's still equivalent, okay? And similarly, A is greater than B, and if you multiply positive C on both sides, it still maintains the equivalent inequality. So this A greater than B is equivalent to A times C greater than B times C if C is positive. Next we have, given A, B are real numbers, can be positive, negative, and C is any negative number, so different from this one. C is positive for the top case. This bottom case, C is any negative number. So if it's negative, given the inequality A less than B, right? If you multiply a negative C on both sides, what happens? You multiply C, right? C is negative on both sides. You need to reverse the original inequality to maintain this inequality to be true or equivalent to the original inequality. So similarly, A greater than B is equivalent to A times C, reverse the inequality, B times C if C is negative. So another way of saying is that if you multiply a negative number to an inequality, ensure to reverse the inequality sign or the symbol. For positive C, if you multiply positive C to an inequality, you don't have to. You do not need to switch this inequality symbol. Okay, maintain the inequality symbol. And similar statements hold for less than or equal to and greater than or equal to. So I can basically rewriting these four inequality using this less than or equal to and greater than or equal to. And again, for the multiplication principle, remember that if A divided by B, right, and C is positive, if you divide by C on both sides, still guarantee is equivalent. Okay. Very similar to the multiplication principle for an equation. If you divide the same number on both sides and that number is positive, okay, positive, guarantee this inequality still equivalent to this inequality. And again, if C is negative, what happens if C is negative? If C is negative, if you divide C on both sides, okay, make sure you reverse the sign. You multiply negative C on both sides of the inequality. If you don't, they're not going to be an equivalent inequality. And it's not true also an inequality. So let's see. I have a simple example here. So given 2 is greater than 1, okay? So this is a true inequality, right? 2 is greater than 1. So what if you multiply by -3 on both sides? You multiply by -3 on both sides, right? And simplify. -3 times 2 is -6. -3 times 1 is -3. Now, look at this inequality. Does -6 greater than -3? No, right? So it's false. So why? What would we do? Again, remember, if you multiply a negative number on both sides of an inequality, like this case, -3, right? What do you need to do? You need to reverse the inequalities. Okay. So if I multiply, I need to reverse the inequality. Okay. If I multiply -3 on both sides of the inequality, I need to reverse the original inequality to the other side, which original is greater than, reverse it becomes negative. Sorry, reverse it becomes less than. And do you see that this is a true inequality? -6 guaranteed less than -3. Okay, and have another example here. Solve this inequality. So part A. Again, when you see solve, right, it means you need to find x. What is x? Now this x has a coefficient of 3/5. So we need to turn this coefficient to 1, right? Because 1 times x is x. So that is what we're looking for. Now, before you simplify the x, there are multiple ways you can approach solving this problem. I probably would start with finding the least common denominator. This coefficient, right, is 3/5. That means the denominator is 5, right? So denominator of this coefficient, 3/5, is 5. This number has a denominator which is 10, right? 1 divided by 10, denominator is 10. So to find LCD, we know that 5 and 10s are denominator, right? 5 and 10s are denominator. That means LCD equal to 10. Okay? So I'm going to multiply 10 on both sides to remove the denominator of these two numbers. So 10 times 3/5 x greater than 10 times you can put parentheses around the coefficient of this left term. Simplify 10 times 3/5, right? You know that you can simplify this 10 and 5 to 2. So I have 2 times 3x, right? 10 divided by 5 is 2. So 2 right here. 3 is just the numerator, so I just carry it to the next line. So greater than 10 times -110. 10 divided by 10 is 1, right? Don't forget the negative sign inside the parentheses. So we're going to have -1 times 1. Okay? Or you want to say 1 times -1. Okay? 10 divided by 10 is 1. This -1 comes from the numerator of inside the parentheses. Simplify further. 2 times 3 is 6x greater than 1 times -1 is -1. We're almost there. So we need to solve for x, right? So far we simplify this fraction inequality to normal fraction inequality. So we need to solve for x. To solve for x, we need to divide by 6 on both sides using the multiplication principle. So now, before you applying the multiplication principle, make sure you verify the number that you divide by. Make sure the number that you use to divide or multiply, if it's positive or negative, you just divide by 6, right? 6 is positive, right? For this case right here, the number you divide, right, or multiply is positive. You maintain the original inequality. So I'm not going to reverse, okay? I may maintain it because the number that I use to divide is positive, okay? So simplify, we have 6 divided by 6 is 6 divided by 6 is 1. So 1 times x greater than negative 1/6. Simplify further, we have x greater than negative 1/6. Okay? So the answer is x greater than negative 1/6. For this part A, let me verify. Yep, so that's part A. And we need to solve part B, which is write the answer in set notation. So I'll give you a moment to copy this before I delete it or erase it. Okay? So we know the answer. Part A is x greater than negative 1/6. I'm just writing the answer, okay, for part A, which is x greater than negative 1/6. For part B, so we need to write the answer in set notation. Remember, set notation means you're going to use the braces, okay? So first, we need a bar. So what variable is that? In this case, it's x, right? So you just copy that variable x right here. Next, you need to describe what x is. We solved for x, right? In part A, we know that x is greater than negative 1/6. So you just copy this condition here. And then you're done. For set notation, for part C, write the answer in interval notation. Remember, interval notation, you're going to use parentheses or bracket, or both, depending on cases. And there are 9 cases. In this case, we have x is greater than negative 1/6. So greater than, right, mean we don't include the endpoint. We don't include this endpoint, negative 1/6. So x is greater than, so it means starting from the endpoint negative 1/6 on to the right, because greater, right? So that means we're going to use parentheses because it's greater than right here. There's no equal sign right here. Parentheses, negative 1/6, greater than, right? So, like it's going to extend to the right, increase to the right. So positive infinity. Yep, so this is the answer for part C. And part D, we have graph this inequality on the number line. When I say graph this inequality, right? This inequality is the original inequality. And so we just saw, right, for x. These two inequalities are equivalent. So if I say graph this, it means I ask you to graph this answer right here. X is greater than negative 1/6 because they are equivalent. All right, let's graph this on the number line. We're almost there. So x, so next negative 1/6, you can pick any number here on the number line. So, negative 1/6 greater than, so to the right, right? Using parentheses. And I'm done. So starting from the left hand side negative 1/6 extend to the right without bound. So this is the answer for part D. Let's see, next example, if I have a couple examples. Let me erase the board here. So next we saw, okay. So I have given given the inequality negative 5y less than or equal to 3.5. Okay. Solve the given inequality, so it's the same question. It means we solve for y in this case. Write the answer in set notation similar. Write the answer in interval notation. Alright? The only thing different is I do not ask you to graph. So okay. Solution. So starting with the original inequality. Again, there are many ways you can use to solve these inequalities. One way you can do is divide by negative 5 both sides. Remember, we want to solve for y. Okay? So we need to eliminate this coefficient negative 5. So we'll start with divide by 5 on both sides. Sorry, negative 5 both sides. Divide by negative 5 on both sides. Now, before you continue, make sure you check with the condition here. Asking, do I divide or multiply the number that is positive or negative, the number I use to multiply to the inequality, does that number positive or negative? Because if it's positive, you can maintain the inequality symbol. If it's negative, you have to reverse the inequality. So what I just did is I used negative 5 to divide on both sides. And this negative 5 is negative. It means I have to reverse the inequality. Okay? So I'm using the bottom part right here. So I cannot use this inequality anymore. I have to switch so that I will have an equivalent inequality. So reverse this. Okay. Simplify, we have, oh sorry, forgot to copy this, negative 5y. So negative 5 divided by negative 5 is positive 1, right? Negative divided by negative is positive. So 1 times y greater than equal to 3.5 divided by negative 0.5 is negative 0.7. Okay? Work it out on the side. You see that 1 times y is y greater than negative 0.7. So solve for the given inequalities, and we just did, which is y greater than or equal to negative 0.7. This is part A. And part B is write the answer in set notation. Set notation meaning using braces, right? Again, what variable is that? This case y, so y right here, such that, so what is the description of the y? We know y, right? So we solve it in part A, which is y is greater than or equal to negative 0.7. So this is the answer for part B in set notation. And for part C,